Hello everyone, welcome back to Code to Enhance Learning video series. In this video series, we are creating projects that integrate advanced physical computing with the world around us using Arduino Uno. Welcome to the last video of the series Noise Detector. In the last episode, we learned how to create a prototype of a project to measure body temperature using LM35 sensor and display it on LCD 16:2. If you missed any part or want to revisit previous videos, you can find the entire series in our YouTube playlist. Be sure and check it and continue learning at your own pace. Today we are going to build an exciting project, a noise detector using Arduino Uno and a sound sensor module. We'll be using M-Block software for the coding part, and so it's going to be fun and easy for both beginners and those familiar with Arduino. Let's get started. Let's start with purpose of the project. In the bustling city during rush hours, the combination of honking cars, buses, motorcycles, and construction work can lead to dangerously high noise levels. Prolonged exposure can lead to hearing damage, increased stress levels, and even cardiovascular issues for residents and commuters. To resolve this problem, in this lesson, we'll make a project noise detector using an E35 analog sound sensor and alert system when it is above threshold level. So here in the working, we can see the LED and buzzer is on whenever the sensor detects a sound above the threshold. For this project, we need following components. First one, Arduino Uno, which is our microcontroller for the project. Then we need a sound sensor module to detect the sound level. Then we need Breadboard. It's a simple prototyping tool to simplify our connections. Then we are using connecting wires so that we can connect our circuit. Then we are using LED and buzzer as output device. And we need one USB cable to program our Arduino board. E35 is an integrated analog sound sensor which detects changes in pressure and converts this into an electrical signal. Our E35 sound sensor has 3 pins: power, ground, and out pin. Now that we have gone over the components and why they are important, let's just jump straight into the steps to connect them and build our circuit. Let's get started.
Let's start with the connections. So I have all the components required over here. Let's start with first connection, that is ground pin and the Arduino pin. So ground pin and 5-volt pin I'm connecting to top 2 rows of our breadboard. So here we can see that I'm connecting it like this. Then next what I have to do is I have to give power to all the components. So let's start with our sound sensor. So here I have one sound sensor. I have connected it over here. Here you can see which pin is which. It's written over here. So a VCC, ground, and the out pin. So VCC will connect to the 5-volt over here on the breadboard, and ground pin will connect on the breadboard as well. So let's do that. So let's fix sound sensor somewhere on the breadboard. Then let's start with the VCC pin. So I'm connecting this VCC pin here where I have taken the 5-volt. Then I'll connect the ground pin to the ground. And then last one is the out pin. So we already know that we have connected out pin, that is sound sensor pin, to the A5 of the Arduino. So I'm connecting it over here. Then let's discuss about our buzzer and LED. So first thing, let's connect the buzzer. Here you can see plus written over here and negative will be the other pin. So let's do that. Plus pin we have to connect to the pin Arduino pin, that is let's connect Arduino pin to, so plus 5 I am connecting to Arduino pin number 2. Connect negative pin to the ground. Now next what we have to do is we'll be using LED. So all of us know which one is the anode and which one is the cathode. So I'll just place LED over here. Then I will connect the ground to the cathode of the LED, and then anode I will connect to the pin number 7 on the Arduino. So let's connect it. Anode will be pin number 7. So for the actual connections I've already done, but you can refer to the table shown in the image. Thank you.
As our circuit is ready, let's start with coding. For coding, we are using MBlock software as other projects. We will walk through the step-by-step process to code our project. We will guide you through each part to help you bring your project to life. So let's dive in and start coding. For coding, we have two parts. One is device code, that is code for our Arduino board, and then one is for sprite code.
With coding part. So first of all we have to go in MBlock. So I have opened MBlock software. Now we have to do it for devices and sprite. So first we'll start with the device. Let's add the device. As we are using Arduino Uno, let's select the Arduino Uno and click on OK. So here you can see I have one Arduino Uno over here and those blocks are added over here. So let's start. So first block we'll be using when Arduino Uno starts up. So what we want to do is we have to show the value on the panda so that we can take the action on our output devices like LED and the buzzer. So first of all, let's create one variable. Click on variable and create it as value. You can name it anything. For now I am naming it as value. Now what we have to do is we will set this value to the analog pin where we have connected our sound sensor. So let's do that. So I have connected sound sensor to A5. So I'll pick this one, read analog pin A5. Then next what we have to do is we have to check the value received from the analog pin. So let's for the checking, let's take the if block, and then we have to check if value is greater than some value. So for that, from the operators we'll select the block greater than, and then what we will do is we'll put this one, read analog pin 5 is greater than 32. So this value might change depending on the calibration of your sensor and the noise around your sensor. So for now I have kept it 32. Then let's do, so what will happen if value is greater than 32? So we have to turn on the LED and then we have to turn on the buzzer. So for that we know we have connected pin number 2 to one output device. So I'll just keep it high so that it will be on, and then second output device we have connected to pin number 7. So I'm keeping both of them high, means on. Then what we have to do is we have to keep them on for some time. So we'll go to control and we'll use wait block and change this number to 0.25. Then after that delay, what I have to do is I have to turn it off. So for that, what I will do, I'll again get set digital pin. I'll set this to 2 and I'll make it low so that it will be off. Same thing I have to do for pin number 7. So I'm doing it now. Okay, and then again I'll wait for some time. So I'll keep this time same, 0.25. And now I want this, everything should happen forever. So for that I'll keep everything inside the forever. Okay, so now I'm done with my sprite code, my device code. And now for the sprite code I need one more block over here. For that I need one extension. So let's add the extension. Let's go to extension and you have to select this upload mode broadcast. Okay, so now I have added. Now with the help of this I will broadcast my value to sprite. So for that we will be using this send message with value. Okay, and what value we have to send is the reading what we are getting from the analog pin. So I'll just check that block over here. So now we are done with our Arduino code. Let's move to our sprite. So for the sprite, what we have to do is whatever value we have received from this device, I want my panda should keep saying that. So for that, again I'll go to extension and I'll use this block or this extension upload more broadcast. Okay, and then here what I have to do is after, like, when I receive the message, I want my panda should keep saying whatever value it has received. Simple, and this is how we are done with our coding part.
Now that our circuit and coding is ready, let's upload the code and check how it is working. So here you can see my LED and buzzer continuously beeping because in the coding we have given condition whenever my value is greater than 32 it should beep, and here you can see it is 78.
And that's how you make a noise detector using an Arduino and a sound sensor with M-Block. It's a simple yet powerful project to understand how sound sensors work and how to integrate them with Arduino. If you found this video series helpful, make sure to like, share and subscribe for more fun projects. Leave any questions or feedback in comments below. Thank you.